This is the second part of our discussion about factors. In this part, I add some sub-materials that we haven't discussed in the first part. For example, like how do we find the projections of a vector along the other vector? And then how do we find the perpendicular distance using the cross products? And after that, I will continue with the equation of the line using the vector concept. If you haven't seen the first video, you can go to the link and then try to understand that first, the video of part 1, before you start with this video, because this video is the continuation of the previous part. So let us start our discussion for the second part. We will start with using the scalar product to find the projection of one vector to another vector. So if you have a vector A and you have another vector B, we can find the projection of vector A on vector B. Yeah, so in this case, the blue one is the projection of vector A on vector B. Because we are using the scalar product, so the result of the projection is also a scalar. Now, using the definition of the scalar product, we can rearrange the expressions into A cos theta equals to factor A dot B divided by magnitude of B. So let's go to the example. Find the scalar projection of 5i minus 4j plus k along the vector 3i minus 2j plus 4k. So if we put into the formula, so we can say this is as vector A and this one as vector B. So that means we are looking for the A cos theta. So the vector A cos theta as the scalar quantity equals to A dot B. So we do the dot product. 5 minus 4, 1 dot 3 minus 2, 4 over the magnitude of B. So the magnitude of B is square root of 3 square plus 2 square plus 4 square equals to, we have 15 plus negative 4 times negative 2 is 4, 8 plus 4 divided by square root of 9 plus 4 plus 16. So equals to 27 over square root of 29. Or if we do the rationalization, we can have 27 square root of 29 over 29. So this is the length of the projection of vector A on vector B. Yeah, the result is a scalar. Now we can use the scalar product to find the perpendicular distance of one point to a vector. In this case, if you see from the diagram, we will find the value, the length of vector C. Now, if you see the right angle triangle here, we can find C by using the Pythagorean theorem. We have the hypotenuse, so we can find the magnitude of A, and then we subtract using the Pythagorean theorem, we can find C. So that's why the formula to find the C is square root of the magnitude of A squared minus the line of the projection of A. So we will use the same example as before to find the C. So from the previous answer, we have that A cos C theta equals to 27 over root of 29. And then the magnitude of A in here is square root of 5 squared plus 4 squared plus 1 squared equals to square root of 25 plus 16 plus 1. So equals to square root of 42. So to find the perpendicular distance, we just use the Pythagorean theorem. So this is square root of 42 squared minus 27 over square root of 29 squared. So the result will be equals to 4.11. So this is the answer. The length of the perpendicular distance is 4.11. Let's continue. We have discussed this in the first part. So I will skip this. And then I can start with the perpendicular distance using the cross product. So if the previous topic we find the perpendicular distance using the scalar product, now we can find the perpendicular distance using the cross product. So given that the function is 5i minus 4j plus k and b equals to 3i minus 2j plus 4k. Find the perpendicular distance C. So now we are using the cross product. So by the definition of the cross product, if you still remember, A cos B, the factor, is equals to magnitude A, magnitude B, sine theta. And in this case, because the theta here, so the perpendicular distance is A sine theta. So if we rearrange the A sine theta, we will have A sine theta equals to A cross B divided by magnitude of B. Now, since A cross B is a vector that perpendicular to vector A and B, we can find the magnitude of A cross B to find the perpendicular distance, because the perpendicular distance is a scalar. So that means the first thing we have to do is find the cross product. So we have 5, negative 4, 1, and then 3, negative 2, 4. So we do the cross product. Do you remember? So for the first row, I have to close the first column and then do the determinant. So negative 4 times 4 is 16, minus with negative 2 times 1, so plus 2. So negative 14. And then for the second row, I close the second column. This is 5, 3. And then 5 times 4 is 20 minus 3. So 17. But don't forget, in the middle, we should put negative. So it's negative 17. Okay, I erase again. The last one, you close the very right. You close 1 and 4, and you have negative 10 minus negative 12. So it's 2. So this is the cross product. And using the formula, so A sine theta equals to the magnitude of the cross product. So negative 14 square plus negative 17 square plus 2 square over B. The B here is this one. So square root of 3 square plus negative 2 square plus 4 square equals to square root of 489 over square root of 29. So if we put into the calculator, we will have 4.11. So this is the same answer as the previous example if we use the scalar product. Yeah, the same thing. So that means we can use either scalar product combined with the Pythagorean theorem, or we can use the cross product. Now, factor equation of a straight line. If we have a straight line, we know that the equation of the straight line is y equals to mx plus c. M is the gradient. C is the y-intercept. Yeah, we know that as y-intercept. Now, gradient. Gradient is the rise over run. We know that gradient is rise over run. So in other words, I can say that the gradient has a direction. For example, if the gradient is equals to 2, so the gradient equals to 2 can be written in the form of 2 over 1. Or maybe I can write in the form of 4 over 2. So what does 2 over 1 mean? 2 over 1. 2 is the rise and 1 is run. So that means it moves 1 unit to the right and 2 units upwards. So that means the gradient is indicating the direction of the line. So with this analogy, I can have the equation of the line in the form of factor formula. So that means the gradient here will be the factor. In this case is the direction factor. And C is one coordinate or I can say it as initial point. So the straight line is uniquely defined by giving two distinct points on the line. If the coordinate A and B are given, then the vectors are known. So we can find the direction vector of AB. Let P be any point on the line AB with position vector xi plus yj plus ck. So P is the position vector of any point on the line. You can see from the diagram, P is a position vector from origin at any point on the line AB. Then we can have R as OP, right? And then using the vector diagram, OP is the same as OA plus AP. While OA is A and AP is AP. Now, you can see this is similar with the general formula of the line equation. Y equals to C plus MX. AP is a linear multiple of AB. Because P is on the line, so AP is a multiple of AB. So that's why we can express AP as the multiple of the direction vector AB. Since AB equals to B minus A, so we can express AP as lambda times B minus A. So we can rewrite these expressions into R equals to A plus lambda times B minus A. So again, you can see that this is the coordinate and AB is the direction vector. And lambda is just a parameter. It's like X. So depends on the value of the parameter. This is the form of vector equation of a line. The parameter lambda can take any real value. It can be positive, negative, integer, or decimal. It can be any real numbers. Different parameter value means we will have different points on the line. Yeah. So the same like the line equation. This one x equals to 2, for example. This one x equals to 3. The same for the vector equation. In this case, the lambda may be is equals to 5. In the other case, the lambda may be equals to 7. So there is similarity between line equation with algebra and the line equation using vector. For example, find the vector equation of the straight line passing through points A and B. So we need the coordinate initial point and the direction vector. The same like line equation, we need gradient and coordinates. So in the vector equation, we need coordinates and the direction vector. Yeah, so we don't use the y equals to mx plus c here, but we use the vector AB, direction vector AB. So direction vector AB is B minus A. So 0, 1, 3, minus 101 equals to negative 1, 1, and 2. So the vector equation is R equals to vector A plus lambda times direction AB, direction vector AB. So A is the initial point. I can use A, 101, plus the parameter lambda times negative 1, 1, 2. Can we use point B as the initial point? Yes, of course, because B is on the line. So we can use B in the equation. R here is indicating the X, Y, and Z. So R is the representation of the vector coordinate X, Y, and Z. This vector equation can be turned into the Cartesian equation. Before we have R equals to 1, 0, 1 plus lambda negative 1, 1, 2. Negative 1, 1, 2. Yeah, correct, yeah? So we can rewrite as x, y, z equals to 1 minus lambda, 0 plus lambda, and 1 plus 2 lambda. Or in other words, we can say for x, y, and z, x is 1 minus lambda, y is lambda, and z is the 1 plus 2 lambda. Yeah, they are taken from here. Now, this form is called as the Cartesian equation. So we can express them in the form of lambda. So that means from here, we have lambda equals to 1 minus x, and lambda equals to y, and then lambda is equals to z minus 1 over 2. So we can make them all the same. So we can rewrite as x minus 1 over negative 1, because I want to put x at the front, yeah, as the first term. And this equals to y over 1 from this one. So I make y minus 0 over 1. And then for the last one from here, z minus 1 over 2 here. So this is called as Cartesian equation. And if you notice, 1, 0, 1 is the initial point. Negative 1, 1, 2 is the direction vector. So the one on the top is the initial point, initial coordinate, while the one at the bottom is the direction vector. So let's see the example. The Cartesian equation of the straight line is given by, rewrite it in vector form. So from the previous example, we can say that the top one is the coordinate initial point. So I can write as r equals to the initial coordinate. So it's 1, -1, and 2. So the opposite sign, yeah, use the opposite sign. So this is 1, this is -1, and 2. Plus, we can use the parameter lambda for the direction factor. The direction factor is 2, 4, -2. So this is the answer. Number 2. Find a vector equation of the line which pass through the point A and parallel to the line BC, where BC are the point of the coordinates. Show that the point D lies on the line. Okay, so there is a line pass through point A and parallel to BC. So that means the direction of the line is equal to the direction of BC. So find the vector BC. The vector BC is C minus B. So this is C, this is B. So it's 2, 1, 0 minus -3, 2, 1 equals to 5, -1, -1. So the equation of the line is the initial point plus lambda times vector BC. So it passed through A, I use the coordinate A, 1, -1, 0, plus lambda times 5, -1, -1. So this is the answer, the equation of the line. Show that the point D lies on the line. So to prove that D is on the line, so we can express AD as the multiple of any point on the line. So I can put D as the coordinate -14, 2, 3 equals to 1, -1, 0 plus lambda 5, -1, -1. So I can simplify this into -15, 3, 3 equals to lambda 5, -1, -1. Can we find the value of lambda? From here, I can have lambda as -3. So because we have a single value of lambda, that means the point D satisfies this equation. So point D lies on the line. Next, about foot of perpendicular. So this is the same as the perpendicular distance. If there's a point P and a straight line of the Cartesian diagram, we can find the perpendicular distance K. So this is called as the foot of perpendicular. Now, we have three methods to find the foot of the perpendicular. The first one, we can use the scalar product. We discussed this at the beginning of this video. The second one, we use the cross product. We discussed this in this video as well. And the third method, we can use the perpendicular vector by using the identity for the perpendicular vector. If you remember, if two vectors are perpendicular, so the dot product or the scalar product of that vector equals to 0. And then we just find the value of the perpendicular vector. For example, find the perpendicular distance from a point 1 to -2 to the line 2, 5, -3k plus lambda 1 minus 1 plus 2. So I can just rewrite this to 5, -3 plus lambda 1, -1 and 2. Okay, maybe I need to draw. This is the line. And this is the coordinate P. The coordinate is 1, 2, and -2. Okay, I can give name. This is A, this is B. Coordinate A, I can use the initial point. So 2, 5, -3. Now, if we want to find the scalar product, we need the vector AP. And then we will find this. Okay. Yeah, the perpendicular distance. So that means we have to find, using the scalar product, we have to find the AP cos theta first. This is the theta, yeah, the angle between the two vectors. So what is the formula? The AP cos theta is equals to AP, vector AP, dot vector AB over magnitude of AB. So vector AP, what is vector AP? So vector AP here is equals to P minus A. So 1 minus 2, 2 minus 5, -2 minus -3. So AP is equals to -1, -3, and 1. So -1, -3, 1, dot AB. AB is the direction vector of the line. So 1, -1, 2. So equals to, and then divide by the magnitude of AB. Square root of 1 square plus 1 square plus 2 square equals to, so -1 plus 3 plus 2 divided by the square root of 6. So equals to 4 over square root of 6. That's the projection of vector AP. Now, to find the perpendicular distance, we just use the Pythagorean theorem. So square root of AP, we don't know the AP, the magnitude of AP. AP magnitude is 1 square plus 3 square plus 1 square. So I just ignore the negative here because the value will be positive. So it's equals to root of 11. So root of 11 square minus, with the projection is 4 over root 6 square. So this is equals to 2.8 times. This is the answer. This is the first method. Now we use the second method. The second method is using the cross product. So the formula is AP sine theta equals to AP cross AB, the magnitude, divided by magnitude of AB. So find the cross product first. AP is -1, -3, 1. AB is 1, -1, 2. So this is the result. So close the first column, yeah, -6, and then minus -1, plus 1. So -5. And then close the second column, it's -2 minus 1. So -3. But don't forget to put negative, so it's +3. And then the last one, close the last column. So it's -1 times -1 is 1 minus -3 plus 3. So 1 plus 3, 4 over square root of AB. Square root of AB again is square root of 6. So equals to square root of 25 plus 9 plus 16 over square root of 6. So equals to square root of 50 divided by square root of 6 equals to 2.89. The same. And the last method, by finding the perpendicular vector. This is quite complicated. Yeah, since we have to find the vector of the vector k in here. So if I rewrite, this is A, this is B, this is B. So we have n here, and we have to find the vector k, which is the perpendicular to the AB. AP is -1, -3, 1. AB is 1, -1, 2. One, -1, and 2. So the equation of AB is 2, 5, -3 plus lambda 1 minus 1, 2. Now, the factor ON, so O is the origin somewhere here, and we can find the position vector of ON. Now we need to find the coordinate of N. The ON here is the coordinate of N, position vector of N, minus position vector of O. Now the coordinate of N is the point on the line. So that means the N will satisfy this equation. So that means coordinate of N is 2 plus lambda, 5 minus lambda, -3 plus 2 lambda from the line equation. This is ON. But now we have to find K. K is the perpendicular vector, which is Pn. So what is Pn? Pn is N minus P. So N is 2 plus lambda, 5 minus lambda, -3 plus 2 lambda, minus P. What is P? P is 1, 2, -2. So equals to 1 plus lambda, 3 minus lambda, and then -3, -2 is -1 plus 2 lambda. So if we use the relationship, of the perpendicular vectors. This one, k dot L equals to 0. So k dot L equals to 0. So k is 1 plus lambda, 3 minus lambda, negative 1 plus 2 lambda, dot L. L is the vector position of the line. 1, negative 1, 2 equals to 0. And then we can calculate 1 plus lambda mean 3 plus lambda minus 2 plus 4 lambda equals to 0. And then we simplify equals to 6 lambda minus 4 equals to 0. So lambda equals to 2 over 3. That means the k here is equals to 1 plus lambda, 3 minus lambda, and negative 1 plus 2 lambda, so 4 over 3, equals to 5 over 3, 7 over 3, and then 1 over 3. To find the perpendicular distance, we need to find the magnitude of k. So the magnitude of k here is equals to 2.89. So all the three results has the same answer. So you may choose one of them, which one that's suitable for you, which one is easier for you, because they have the same answer. Intersection of two lines. If we have two lines and they are not parallel, that means there are two possibilities. The first one, they don't intersect, or they intersect at the point, because two parallel lines cannot have intersection point. So if they don't intersect, that means the possibilities are either they don't intersect or they intersect at a point. If the lines are not intersect each other, so we call it as a skew line. Yeah, usually you can see it in the tree diagram. Yeah, if this is line and this is another line, this is not parallel. See, this is skew because no intersection point. But this one is intersection point. They are intersect. So that means if you want to check or we want to find the intersection point, first we have to make sure that they are not parallel. And then second one, we have to find the common coordinate. So if the lines are intersecting, they have common coordinate. Let's see the example. The line L and M have vector equations. Show that these two lines intersect and find their point of intersection. Okay, we write L, R equals to 0, 2 minus 2, plus lambda 1 minus 1, 0. For M, R equals to 1, 1, negative 2, plus mu 0, 1, negative 1. So that means for the coordinates of the point of intersection in L is 0 plus lambda, 2 minus lambda, negative 2, plus 0. This is the point of intersection. And the point of intersection of point M is 1 plus 0, 1 plus mu, and negative 2 minus mu. Let's check first. The direction vector of the two lines are not same, so they are not parallel. So we can check if they are intersect or not. If they are intersect, they have common coordinate, so we can make them the same. So 0 plus lambda, I just simply write lambda, yeah. 2 minus lambda, negative 2, should be equals with 1 plus mu, and then negative 2 minus mu. So from here, we can see that lambda is equals to 1. And from the third row, we can have negative 2 equals to negative 2 minus mu. So mu equals to 0. Now, to know the intersection point, we have to check these two values on the second row. So it's 2 minus 1, and the mu is 0. It's 1 plus 0. So 1 equals to 1. They have the same. That means because the y coordinates are the same, so they are intersect. The conclusion, they are intersect. And what is the intersection point? The intersection point is 1. Just choose one of them. I choose the right one. 1 plus mu, negative 2 minus mu. Put the mu is 0, so it's 1, 1, negative 2. So this is the answer. This is the exercise. You can try by yourself. And then the last part in here, angle between two lines. So we use the same concept, the same method in subchapter 2.6.3. Let's see the example. Yeah, we can use the scalar product in here. Find the acute angle between the lines with vector equation. Okay, so this is 2, 1, 1 plus t, 3 minus 8 minus 1. And 7, 4, 1 plus s, 2, 2, and 3. So if you remember the formula to find the angle between two lines, so cos theta equals to factor A dot factor B divided by magnitude A, magnitude B. Factor A and B here are the direction vector of the line. So this is A and this is B. So we can just put 2, 2, 3 dot 3, negative 8, negative 1 over square root of 17, square root of 74. So we can calculate it's 6 minus 16, negative 10 minus 3. So negative 13, square root of 17, square root of 74. Since the question is asking for the acute angle, so we can add the absolute sign here to remove the negative sign. So it's 13 over square root of 17, square root of 74. So the theta is equals to inverse cos of 13 over square root of 17 square root of 74. So it's equals to 68.5. That's it. Okay, so this is the last topic in this lecture. Thank you for watching and see you. Bye.